My name is Daisy Luna. I'm going to teach this lesson in the subject of biology, and my objective for this video is to teach students the steps in the synthesis of proteins. The video is designed to give students who miss class the opportunity to catch up on the concepts that they missed. Hi guys! So if you're watching this video, it means you probably missed the lab activity in class. Don't worry though, I'll make sure you're caught up on everything you need to know. So in lab, we learned about the synthesis of proteins, which is just a fancy way of saying how we make proteins. There are essentially three major steps in the synthesis of proteins, and that is transcription, RNA processing, and translation. There are four major players that we will look at that are vital to making proteins. They are RNA polymerase, spliceosome, tRNA, and rRNA. In class, your classmates took on the role of each one of these major players, but for the purpose of this video, I'll just show you what each of these players do. So our first step is transcription. This occurs in the nucleus. Here is where our genetic material, the DNA, is stored. As you can see here, we have double-stranded DNA. Here in the nucleus, we can see our first player is ready to get this process started. This is RNA polymerase. Its job is to make mRNA using DNA as a template. So how does it know which strand to use as a template? Well, if we look closely, we can see where the 5' end is and where the 3' end is. From this, we can determine that the strand going from 5' to 3' is our sense strand, and the strand going from 3' to 5' is our antisense strand, which this happens to be our template strand. Using this, RNA polymerase can make an mRNA strand that is complementary to our template strand. Remember that when making RNA, it uses uracil instead of thymine, so make sure you change those T's to U's. So now we have mRNA, right? Well, sort of. We actually have something called pre-mRNA. Before we can leave the nucleus to create proteins, our mRNA needs to be processed, which coincidentally leads us to our next step, RNA processing. Here we can introduce another one of our major players, the spliceosome. In class, I represented the spliceosome as scissors, just like I am here in this video. And the reason for that is because its job is to cut up our pre-mRNA in order to make it ready to leave the nucleus. The spliceosome cuts out something we call introns. These are sections of our genetic code that don't code for anything. For today's lesson, our intron code is UUAAUU. This means we will cut out sections containing the nucleotides UUAAUU. Do you see it anywhere? Here I've highlighted the introns in our pre-mRNA. Once we've cut the introns out, we are left with something called the exon. These are the coding segments of our mRNA. The exons get connected together, leaving us with a newly synthesized mRNA strand that is ready to leave the nucleus. Remember folks, everything that just occurred happened right here in the nucleus. Now we can move on to our last major phase in the synthesis of proteins. This is called translation. After our mRNA has been synthesized in the nucleus, it is ready to leave the Out here, our mRNA is directed to the ribosomes. Here, we find another one of our major players in the synthesis of proteins. This is our RNA. The R here stands for ribosome. Our mRNA strand gets attached to the ribosome here. Out here in the cytosol, we also have our last major player as well, tRNA. We also have a lot of amino acids floating around freely. Proteins are made of amino acids, so these are our building blocks for making proteins. For the sake of this class, we don't need to know the specifics of what occurs here, though if you are interested, I'd love to come talk to you about it. But what you do need to know is that tRNA and rRNA work together to create a protein. Let's take a look at our mRNA. 3 base pairs make up something we call a codon. These are our units of genetic code. They correspond to an amino acid. You should have a codon sheet in which you can translate genetic code into an amino acid. I won't go through each of these, but I will help you out a little bit. So if we take a look at our first codon, it's AUG. Now if we take a look at our codon sheet, we can see that AUG corresponds with the amino acid methionine, or MET. So we know that we can put MET down. So now it's your turn. For the next codons, I would like you guys to translate them using the codon sheet and find the corresponding amino acid. Pause this video, and when you're done, unpause it. So this is what you should end up with, these 3 distinct amino acids that come together to form a protein. This is a pretty simple way of how proteins are made, but essentially this is what happens. Some proteins are made of many amino acids, and not just 3. So there you guys have it. You guys made a protein. I hope I broke this down in a way that you guys can understand. If not, please come to me with any questions you may have. Feel free to send me an email or see me after class. I really enjoyed making this video. I really hope that you enjoy watching it too. I'll see you guys in class.